This video accompanies Homework 1. In Homework 1, we were to construct a subscriber and a publisher. The publisher would publish command velocities for a two-wheel robot, the left and right wheels. The subscriber would then read the publisher's output and use the Rohm-Kutta method to integrate the equations of motion and produce the pose for the two-wheeled robot. In this video, we'll go through some preliminary remarks, and then we will show output from the project. So here you can see our file. We have a Catkin homework, Catkin HW directory. Within that is the source code, and here is the project name, forward2wsim. Within the forward2wsim folder are launch folders and the source code folder. The launch folder contains the launch file. The source code folder contains the two nodes, the publishing node here and the simulation or the subscriber node. Also within the file is the cmakelist.txt, which was created when we used the create package command under Catkin, and we had to put in some additional text in there in order to point it to the executable file for this package. There's also this package.xml, which was created when we executed the create package command. We didn't have to alter that at all. Now let's go and view some output. In order to view the output, the first thing we need to do is to initiate the raw score. So here you see one terminal where the raw score is initiated. Started raw score service, you can see that. Initiating the raw score, that raw score controls the messaging service between the subscriber and the publisher, among other functions. And now we're going to go ahead and launch our launch file. We're in the Catkin-HW workspace, and we'll go ahead and launch that file. Now that we've launched the file, we can go ahead and view output. Let's first make a list of the topics that we can see using the ROS topic list command. And here we can see the various topics. Among them are the pose and the velocity RL. The velocity RL gives the velocity of the right and left wheel, and the pose is the position, the X, Y, and theta position of the robot. Let's actually view the echo or the pose, with this echo command. And now we can see the numbers being generated from the messenger service. The numbers are coming very slowly. That's because I've set the numbers to come slowly so that we can actually display and read them as they come. Let's stop it and we can explain the output. So these are X, Y, and theta components of the robot. The X gives the X position in the XY plane of the midpoint of the axle. The Y gives the Y position of the midpoint of the axle, and this value theta gives the orientation of the mobile robot, or the direction that it's pointing. For this output, the command velocities were a fixed value on top of a sinusoidal value to the left wheel. I also have a case in which I commanded the robot to go in a circle, and it completed the circle properly, as expected, which allowed me to run a test case and assure that the code was working properly. End of video.